right. I have the paper test, practice test on paper on the screen. I can also open the one on where to sign if necessary. So I assume that you have done all these problems, at least, one of them, one practice test. So I'm here to answer your questions if you had any problem. Now, you know that the answers are there for the one in the paper. And so you would have probably checked all the answers. And so if you had anything that you couldn't understand, then you should ask me. So any question from page 1 of the printed practice test, the one on paper right here.
I had a question about number 2. I kind of got confused because fractions got involved.
Yeah. Which one?
For number 2.
Okay. All right, 1 second. I have to take attendance again. All right, question number 2, graph the equation 2x minus 5y equal to 10. So we need to find 2 points. Hold on. Okay, so we need to find at least 2 points on the graph. So we can plug in, actually it says find intercepts. So we have to find the intercepts. To find the intercepts, to find the x-intercept, you need to set the y to 0. To find y-intercept, you need to set the x to 0. So I'm going to set the x to 0 in the equation 2x minus 5y equal to 10. So if I set x to 0, this is 0. So the equation becomes negative 5y equal to 10. Dividing by negative 5, I get negative 2. So y equal to negative 2. Now, if I play, so this is your y-intercept. And to find x-intercept, I had to set the y-coordinate to 0 in the equation. So if I set the y to 0, then I get 2x equal to 10. So x equal to 5. So 5, 0. All right, so on the axis system, you just have to draw it here. Or let me see. Okay, I'm going to use this axis system to draw the graph. So that's going to be 0 minus 2. So 0 minus 2 will be on the y-axis, 2 points down. So right there, 0 minus 2. And then 5, 0. That's the x-intercept. 2, 3, 4, 5. So that's 5, 0. So I need to join them by a line to get the graph. So okay, so that's my graph right there. There are no fractions. The x-intercept is 5, 0. Y-intercept is 0, negative 2.
Okay, because the way I went about it was basically isolating the x alone, then dividing it to the 5, 10, 5y minus 10.
Okay, you don't need to do that.
Okay.
That will bring in fraction. That's unnecessary.
Okay, thank you.
Okay, anything else from page 1? Okay, moving to page 2.
Oh, I had a problem with number 7, trying to find that if it was intersecting or parallel. I was looking back at our notes, and the only thing I don't have is how to find the intersecting. I got the coincidental and the parallel part, but the intersecting I had a problem with.
Okay, you just have to, there are 2 ways to solve that problem. One is to find slope and y-intercept of both equations, and then use the fact that if slope and y-intercept both are equal, then they are coincident lines. They have to be on top of each other. If uh, if the slopes are equal but the y-intercepts are not equal, then they are parallel. And if slopes are not equal, and if the slopes are not equal, then they are intersecting. If the lines have 2 different slopes, then one line would be like this. Let me clear the board here. Okay, so if the slopes are equal, then the lines could be parallel like this, only then slopes are equal, or they could be coincident, one on top of each other. So to distinguish these 2 cases, you have to look at the y-intercepts as well. In this case, in the coincident case, both lines have same y-intercept. In the parallel case, they have different y-intercepts. Now, if the 2 lines have different slopes, then one line is like this, the other line is like this, they're going to meet somewhere. If they're not parallel, they're going to meet somewhere. That's when they're intersecting. So finding slope and y-intercept of both equations would be one way. The other way is to just solve them. So if you just simultaneously solve the equations, then I'm going to explain on the board. If there is a solution, the solution will be the point of intersection. So if there is a solution for the 2 equations, that means the 2 equations are going to meet somewhere. Only then there's a point of intersection, and the point you find by solving the values x and y you find by solving them will be the coordinates of the point of intersection. Now, if they're going to be parallel, then when you simultaneously solve them, you will not get a solution. Instead, you will get something invalid. So if the solution process ends up giving you something invalid, that would indicate that the system is parallel. And if the lines are coincident, then you will get something valid, but you will not find the solution. Like when you solve by elimination method, the whole thing will get eliminated and you get 0 equal to 0. That's very commonly what you get. So that means, this means they're coincident. Getting something like 0 equal to 2 when you try to solve them indicates that they are parallel. So those are the ideas we learned in class. So I'm going to solve this one and show you what happens. So let's see, problem number 7 is 3x minus 5y equal to 4, x plus 2y equal to 7. So I'm going to use elimination method to solve. So let's say I want to eliminate the x. So I need to multiply this equation by what? Anybody?
-3.
-3. So this is still my first equation. My second equation, 1 second, keep it. I'm multiplying second equation by -3. That will give you -3x minus 6y equal to -21. So now I'm going to add the first equation and the second equation, 1 plus 2. That will end up canceling the x's. So minus 5y minus 6y is minus 11y equal to minus 17. Minus 17. Yes. So therefore, y equal to 17 over 11. All right, we can stop there. Right there. I'm getting a value for the y. So, if they're going to be parallel, I will not get a value for x or y. And if they're coincident, again, I will not get value for x or y. So I'm getting a value for y means I don't have to proceed to solve for x. It's clear that they are intersecting. Okay, there is a solution.
Okay, so basically that's what I kept having an issue with. I tried it multiple times and basically it just stopped. Like it didn't give me an actual solution. So would that just clarify that it's intersecting?
Yes, I found solution. See, I'm use the elimination method and I'm finding solution. I'm finding a value for y. I don't have to find the x, but if there's a y, that means there will be an x. There'll be a value for x. So that means there is a solution, which means they are intersecting somewhere. Okay. You said you didn't find any solution?
Yeah, I went about it like multiple ways and I guess I just kept going about it the wrong way.
Yeah, you must have made some mistake. As you can see, I'm finding a solution here. I found the y, and that is enough to conclude that there is solution and therefore the lines are intersecting.
Okay, thank you.
You're welcome. Anything else from page 102?
Number 12
Okay,
from page 2.
all right. Number 12 is again elimination method, but I I can see why you had a problem with that. Probably the fraction, so I'm going to show you how to work with that. The first equation has fractions. Second equation doesn't. So it's better to eliminate the fractions first. I can multiply by one number that will cancel with the denominator. So what is the smallest number I can multiply by so that both denominators will cancel out?
3?
3 is not going to do it because 3 goes into 6 2 times. So the 2 will remain in the denominator. They will be in the second, the 5 over 6. 5 over 6 multiplied by 3 is 5 over 2. So I will still have a fraction there.
Could it be 1?
Why would you multiply by 1? It doesn't change anything, right? We are going to multiply the first equation by a number that would eliminate all of the denominators. Anybody see the number?
9 or 6?
6 is the right number because 6 is divisible by both of those denominators. 3 divides to 6 and 6 divides to 6, right? So that's the kind of number you need. Now, always, if you just multiply those two denominators, 3 times 6, that's equal to 18, and the 18 will work. The only thing is you will be blowing up the numbers into larger numbers, but it will work. But if you find the least common denominator, that'll be the best way. So least common denominator of 3 and 6 is 6. In other words, 6 is the smallest number that is divisible by both 3 and 6. So therefore, I'm copying the equation 1/3 x plus 5/6y equal to 1. I'm going to multiply this one by 6 so that the denominators will cancel out. You can see that 6 times 1/3 is 2, right? 6 times 1 over 3. 3 divides the 6 into 2. So I get 2x. And 6 times 5 over 6 is 5. The 6 cancels out. So 5y equal to 6 times 1 is 6. So that is my new first equation. And I copy the other one. The other one doesn't have denominators, so I can work with it just the way it is. So 3x minus 2y equal to minus 10. Now I can proceed to solve by elimination method. In this case, there is no one number that I can multiply by to eliminate either one. If I want to eliminate the y, for example, then I need to multiply this equation by the 2 here, and this equation, second equation, by the 5 there. That's the only way I can find matching numbers. So that will give me 4x plus 10y equal to 12. Second equation is now 15x minus 10y equal to minus 50. So now, as you can see, the y's are going to cancel out when I add them. So I have 19x equal to 38, minus 38. Dividing by 19, x is equal to minus 2. So I found the x. All I have to do is go back to one of the original equations. I'll plug this into the first equation. 2 times minus 2 plus 5y equal to 6. So minus 4 plus 5y equal to 6. Adding 4 to both sides, 5y equal to 10, y equal to 2. So the solution is x equal to minus 2, y equal to 2. That's your answer.
Okay, thank you.
You're welcome. Anything else from page 2? All right, moving to page 3. All right, page 4.
Number 28.
All right, 28. Jane must go on a diet for next 3 months. She has 2 low-calorie foods to choose from, but she must probably combine them to consume 600 grams of vitamins, minerals. So vitamins and minerals are our concern. So you need to organize this data into columns and rows. So I'm going to write vitamin as my row title and calories. Now, to get these vitamins and calories, she's going to eat food 1 and food 2. And food 1 provides 2 units of vitamin. So food 1 would be my column title. Food 2 is the second column title. And then you write down how many vitamins we are getting. From food 1, we are getting 2 units of vitamin, 3 minerals. 2 vitamin, 3. Oh, that's not calories, minerals. Sorry about that. 3 minerals. And food 2 gives you 4 units and 2 units. 4 and 2. So that's from each unit of food 1 and food 1 unit. That means like 1 pound of food, 1 ounce, whatever that is. We don't really have to worry about it. So 1 unit of food F1 gives you this much of vitamin and mineral. 1 pound of F2 gives you 4 and 2. Now the question is how much of each food she should eat so that she will get the required vitamins and minerals. So let's write down those required numbers across the vitamin and mineral rows. Across vitamin row, we need to write down 600. That's the required vitamin. Required mineral is 540. Okay, and now the question is how much of each food she should eat. So that question becomes our unknown quantities. So X pounds of food F1 and Y pounds of food F2 should be eaten. So that's our assumption. So with that, I can now set up the equations. Okay, so if from 1 unit of food F1, or let's call it 1 pound. 1 pound, I'm getting 2 units of vitamin. I'm eating X pounds. So I'll get 2 times X vitamins from those. And then look at F2. From each pound of F2, I get 4 vitamins. And from Y pounds, I get 4 Y vitamins. So 4 Y. And if I add them, that's total vitamins. So first calculate total vitamins you're getting from the food amount X and Y. And it must be equal to 600. And similarly, minerals you end up getting would be 3x plus 2y, and that should be equal to 540. So now you need to proceed to solve it. So I assume you know how to solve it. You probably had trouble setting it up, right?
Yes.
Okay. All right. Anything else among these application problems? Okay. Then moving to page 5, set theory.
For number 36, I kind of was a little confused
Okay. 36.
because I was trying to use the NA union B formula.
Yeah, the union rule is not going to apply here. The
Yeah.
union rule applies to the previous one for 35, but not for 36, because as you can see, there is complement B bar in there. So if there is complements, then union rule cannot be used. Okay. So the only method you can use is a Venn diagram. A Venn diagram applies in any case. It will apply in number 35 also, but the union rule is easier to use in 35. But 36 requires using Venn diagram. So let me show you how to do that. On the Venn diagram, this is universal set, and number of elements in the universal set is 30. And then there are 2 sets involved, A and B. And it says count of A intersection B is 6. So A intersection B is the middle section. So put the 6 there. And count of A intersection B bar. Where would that be? A intersection B bar.
With just A?
The part of A that's on the left side. This middle part is 6. Only this part is A intersection B bar. Okay, which A intersection B bar is the part of A that's also in B bar. B bar is the outside of B. So the area that's common to A and B bar is this, the shaded region. So that's where the number 10 goes. So 10 elements are here. And the question is, what is count of A? Now you can see now the count of A. What is it?
16?
16. So 16 is the answer. We cannot find the B, count of B if they ask for, because they didn't give us enough information. There are 2 pieces missing. This is unknown and the outside is unknown. So not enough information to be able to find B, but we can find count of A, which is the question, and that's 16. So that finishes that. Anything else? Anything else on page 5 or 6? This is showing as page 2 for some reason, but it's 6.
Maybe some help with G on number 30?
Number 30, G, okay, 30. Determine the following sets, and G says B intersection C intersection E. So 30G, B intersection C intersection E. So to find that, you can just start by finding B intersection C. So let's write, I'm going to write it down. B intersection C, the B is 13579. So I have 3. 5, 7. 1, 3, 5, 7. So 1, 3, 5, 7. You can see that, right? Those are the elements common to B and C. And now I need to find what is common to this and the E. When it comes to these three intersections, you can do them in any order. You could find C intersection E first and then find the intersection with B. It doesn't matter which order you use. Answer will be the same. So I have B intersection C here. I need to find what is common to that and the E. And I see that 3 is there and 7 is there. That's it. So therefore, 3 and 7. All right.
Yes.
Okay. Anything else? Anybody?
How about
Number H.
H. Okay.
I meant later, letter H.
Letter H from 30, letter H. That says A union E prime intersection D. Okay, so that means I had to start with A union E. So start with, if in the web design test, you only enter the answer. So you had to do these on a scrap paper. You are allowed to have blank scrap papers in front of you, and you should have some. So A union E would be 3, 5, 7, 2, 3, 6, 7, 9. So I get 2, 3, 5, 6, 7, 9. Okay, that's A union E. Now, next thing is A union E prime, complement. So that would be all the elements of universal set that are not in here. That will be 0, 1, 2, 3, 4, 5, 6, 7, 8. That's it. 0, 1, 4, 8. I need to find the intersection of this with D. So A union E prime intersection with D. So you need to find what is common to these elements and the D. D is 0, 2, 4, 6, 8. So I have 0, 4, and 8 that are common. So that's your answer right there. 0, 4, 8.
Okay, thank you.
Anything else?
And
Page
can I
5.
have output number E?
E on 30.
Yes.
Okay. 30E, B union D bar. Okay, erase the board. Doing part E in problem 30, says B union D complement. So let's find B union D first. And that will be 1, 3, 5, 7, 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 7, 8, 9. Looks like that's equal to universal set, right? Yes. So we got entire universal set.
Yeah, isn't the answer phi, right?
Yes.
Okay.
So the complement of that is phi. There's nothing there, nothing in the complement.
For letter F,
Yep.
so it's asking for B prime intersection C, but it says for the answer, it's not including 0.
Okay, let me do it and see. B bar would be everything outside of B. B has 1, 3, 5, 7, 9. So B bar would be 0, 2, 4, 6, 8, 7, 9, 8. Okay, so that's our B bar. And we need B bar intersection C. Okay, so what is common to 0, 2, 4, 6, 8, and C? I get 2, 4, 6. 0, 2, 4, 6, 8. So we have 2, 4, and 6. That's it.
Yeah, I figured it out. It's because C doesn't include 0.
Right. That's all you have. Okay. Anything else? All right, moving to next page. It's actually page 6.
Could you do number 44?
44, okay. Count of A intersection B bar. Well, if I'm doing any of those, I need to work out the numbers on the Venn diagram. So let's draw the Venn diagram. Let's clear the board. So I'm going to do the problem 44, which means I had to put all the numbers on the Venn diagram, and that's what I'm trying to do. So let's start with this. And all right, it's not going to work. Let me just draw the picture. Count of A intersection B is 7, B intersection C is 9, A intersection C is 11. A, B, C have 22, A has 22, B has 15, C 25. What is common to all three is 3. There are 3 elements common to all 3. So that 3 goes here. The small section that's common to all 3 sets is 3. Now we can use the other numbers. A intersection B is 7. A intersection B is all of this, but a portion of that is 3, right? This is 3. So I had to subtract that 3 to calculate the remaining section. So 7 minus 3, 4. That would be here. That's 4. Similarly, B intersection C is 9, B intersection C is 9, so 9 minus 3, 6 goes here. A intersection C is 11, so 11 minus 3 is 8, goes here. Okay, so those are the information given. So we can now find remaining sections. For example, in A, I know these 3 sections, 8 and 4 and 3. So add them up, you get 15, take away from 22, that gives you 7. I added 8, 3, and 4, and took away from 22, that gives you 7. 6, 4, and 3, 13, take away from 15, you get 2. 6, 3, 9, plus 8, 17, take away from 25, you get 8. Okay, finally, to find the outside of 3 circles, I can add up everything inside the 3 circles. So that's 25, 32, 36, 38. I'm getting 38, and the universal set has 47. So I take away 38 from that. That gives you 19. No, 9 actually, sorry. 9 elements outside. So now we have all the sections, so we can answer all those questions. Well, 1 second. So going to the question 44, A intersection B bar, the part of A that's outside of B. Part of A that's outside of B is both 7 and 8 together. So 15 is the answer. So question 44, answer is 15. Okay, you got that?
Yeah, thank you.
Mhm. Any of the other questions in that problem? 37 to 43. Anybody has any question there?
38.
38. Okay. Count of A union B union C. That means you have to add up all the numbers in the three circles. And we just did that. I got 38. So that's the answer for that. That's the
And
answer for the 40.
41?
Which one did you ask for? I'm sorry.
41?
Oh, you asked for 41. Sorry, I was reading the wrong question. My answer 38 is correct for problem 38. Problem 38, answer is 38. You said 41, right? Okay, let's go to 41, which is A union B bar intersection C. Okay, A union B bar intersection C. So first we had to identify what that is. A union B bar means everything outside of A and B combined. So everything outside of A and B combined would be 8 and 9. That's what's outside A and B combined, 8 and 9. But we need to find what is common to that and C. That means 8. This is the part that's outside of A union B, but inside C. Okay, so.
Okay.
Okay, anything else on this page?
I'm sorry, but what numbers did we add together to get 38 specifically?
Problem number 38, it's count of A union B union C. So that means all of the A, B, and C together, which means you had to add
So
up.
22 plus 15 plus 25?
No, I started with 25, which is all of the sections within C, right? All of the sections within C add up to 25, right? To that, I added 7, 4, and 2.
Oh, okay, because the numbers that are in the intersection are also in the other circles?
Right. You cannot
Okay.
just add the set 22, the 22, 15, and 25. If you add them, you're counting the intersections more than once.
Okay, that would be including it the 3 times, right?
Right. Right.
Okay.
That's why you had to really add the sections. So if I add up all the sections in C, that's 25. You know that it's already 25, right? So everything in C is 25. To that, you need to add the 7, 4, and 2. That'll give you the union of 3. That's what 38 is. Okay.
I'm sorry. No, I was trying to do the math. I'm sorry. What numbers did you say right now equal to the 38?
Problem 38.
Yeah, for the answer 38, what numbers did you add together?
Okay, the numbers were all the elements in C, all the sections in C would add up to 25. We already know 25, right?
Okay.
Plus 7 in this section, 4 in this section, 2 in this section.
Okay.
Okay, that will give you 38. Okay, anything else from this page? All right, moving to next page, which is supposed to be, I don't know why the page numbers got messed up. This is 6, so this is 7. Page 7 has all these factorials and permutation and combination. Any question there? When it comes to the application problems of permutation combination, you'll have to first determine whether it's a permutation or combination. That will depend on whether we are counting rearrangements or not. So you need to ask the question, does order matter here? Are we counting rearrangements or just counting some collections? That's the question you need to ask. So look at 54. There are 12 rabbits in a farm. The farmer needs to pick 5 rabbits for a health test. How many ways are there to pick them? So is that combination or permutation?
Combination.
Combination. You're only selecting 5. You're not arranging them. You're not counting any arrangements of those. So that'll be combination 12, 5. Okay, 55 says a musician is planning to play 6 pieces in a recital. He has 11 pieces to choose from. How many different recitals are possible? Is that permutation or combination?
Permutation.
Permutation, because a recital means order matters. Different arrangement of songs will make different recital. So there'll be permutation of 11, 6.
Can you help me with number 51D?
Okay, 51D. All right, clear the board. Okay, it says 51D says 22 factorial over 22 minus 4 factorial times 4 factorial. That's same as 22 factorial over 22 minus 4 is 18 factorial times 4 factorial. Next step, you cannot find 22 factorial on your calculator. It'll overflow. So that's why you had to use the technique we learned for simplifying. Take the larger number in the denominator and combine with the numerator, these two. This combination will be equal to a product of 22, 21, times 20. Where do I stop?
At 19.
At 19, right. After that, you only have 4 factorial left in the denominator, which is equal to 4 times 3 times 2. You don't have to write the 1. Now you need to cancel common factors. I'm going to cancel 4 with the 20 to get 5. And 2 divides 22 into 11. 3 divides 21 into 7. So you have 11 times 7 times 5 times 19. And this can be done in the calculator. So if you do it correctly, all of the denominators will cancel with something to give you only numbers in the numerator to multiply. And the product of these will be the answer. Okay, anything else? Okay, if there's nothing on that page, then go to next page. Any problem here?
Number 61.
Okay, 61. A class consists of 7 juniors and 6 seniors. 7 juniors, 6 seniors. 1 second. From those, we need 5 students. A team of 5 students are needed. So first part of the question, how many ways are there to form the team if there are no restrictions? So part A has no restriction. That means the 5 members can be any number of, 5 student committee can contain all juniors, all seniors, or some juniors and seniors, it doesn't matter. So that means from all of the 13, 7 plus 6 is 13, we need to select 5, any 5. That's what that means. No restriction means just from the 13, select any 5. First of all, we are making a committee, a team. So it's not, I mean, the order doesn't matter. You're not rearranging, you're not rearranging. Rearrangements are not counted as different committees because a committee means a group of people. Order doesn't matter. So therefore it's combination. Combination of 13, comma 5 will be the first part. And apply the formula, that'll be 13 factorial over 13 minus 5 is 8 factorial times 5 factorial. And then to simplify this part, combine the larger denominator to the numerator, you get 13 times 12, 11, 10, 9. And 5 factorial would be these. 5 times 2 is a 10, cancels with that. 4 times 3 is 12, cancels with the 12. So you have 13 times 9 times 11. Multiply them in the calculator to get the answer. Part B says, if the team of 5 must consist of exactly 3 juniors. So you need 3 juniors means the remaining 2 will have to be seniors. So that means you have to first select the number of ways of getting the 3 juniors from the 7 juniors. That'll be combination 7, 3. So now we still have to select 2 from the seniors. So 2 will come from 6. So see 6, 2 ways to do that. And we are going to combine we can combine each one committee here to each committee here to make a new committee. So that's when multiplication principle applies. So multiply them to get the answer. So I know you know how to simplify them. So simplify, that'll be
Yeah.
it. Okay.
Thank you.
You're welcome. You want the part C also?
Yes.
Okay. For part C, I'll write the expression and you know how to simplify. The 5 team must consist of at least 3 juniors. So at least 3 means 3 or more. So we can write down all the options. 3 juniors and 2 seniors, or 4 juniors and 1 senior, or 5 juniors. That's it. No other option. So that means the count of all these different ways of making the committee will be C 7, 3. The 3 juniors have to come from 7. The 2 seniors have to come from the 6. So C 6, 2. So that would be same as what you found in part B. So that same number goes here. Plus, wherever you have or, you need a plus. 4 seniors will come from 7. So C7, 4 times C6, 1. Only 1 senior. Plus 5 juniors would be C7, 5. No seniors here. So you have to simplify each expression. This expression was already simplified in part B. Simplify this, and add all of them up. That'll be your answer for part C.
Okay. Thank you.
You're welcome. Going on to next page.
I actually needed help with 58A.
Okay, going back to 58A. How many 7-letter code words can be made using the letters X and Y? Okay, so you're allowed to use only the 2 letters X and Y, and you're going to make 7-letter code word. So that clearly means you have to repeat X and Y. So repetition has to be allowed. So let me write some of those code words. 7-letter code words with X and Y. So that would be something like XX, Y, X, Y, Y, Y. So that's one example of such a code word. But it could be all X's. So all the possibilities, everything is allowed. So how many such code words are there is the question. Now, clearly we cannot count by writing them down. So what technique. We had to use one of the counting techniques we learned. So can anybody tell me what technique is going to apply here?
Box method.
The box method, exactly. Because whenever repetition is allowed, the box method is the only way. So 7 letters are going to go in the code word. So 7 boxes to fill. And then you ask the question in how many ways they can be filled. X and Y are the only choice. So, and repetition is allowed. So how many different ways are there to fill the first one?
2.
2. For the second one?
2.
2. So for all of them, 2 ways. X or Y can go in any of them. Repetition is allowed here. So 2 to the power 7 will be the answer. You have to calculate that in your calculator. 128. Okay.
Okay, and how would we solve for B?
Part B, okay. So this is part A. Part B says how many 7-letter code words can be made using the letters X and Y, having exactly 3 X's. Okay, so 3 X's means this is not box method, but I'm going to use box to explain. So let's say we need to place X's and Y's, but we are allowed to place only 3 X's. So that means if I put the X's here, here, and here, that's one code. If I put them here, here, and here, that's another. So it comes down to asking in how many ways can I choose 3 boxes from the 7 for placing the X's. The other boxes will be Y automatically. 1 second. Students are coming in very late. All right, so the question is, we basically have to choose 3 boxes for the X's. The other ones will be automatically Y's. So in how many ways can I choose 3 boxes from 7 boxes? That's the question here. Only selecting 3 boxes because we're not rearranging. I mean, let's say I put X's here and here and here. Rearranging these X's will not give us another code. So it's not rearrangement. It's just selecting 3 boxes for 3 X's. That'll be combination 7, 3. That's how many ways are there to select 3 boxes. So that's how many ways that's how many codes are going to have 3 X's. All right, you simplify that, that'll be your answer.
Okay, thank you. See, I was having an issue with trying to figure out if it was computation or permutation for this one.
Okay, now
Thank you.
you see why it's not permutation, right? Once you place,
Because we're selecting 3, right?
yeah, you're selecting 3. Rearranging those X's will not give you different code. So it's just selections. That's why
Okay.
C7, 3. We did problem like this using 0 and 1. Instead of 0 and 1, we have X and Y here. That's the only difference.
Yeah, I also have a question about that later on when we get to it.
Okay. So this problem and the problem involving 0 and 1 are very similar, very, very much the same. Okay.
Actually, it's question 57.
Okay. Oh yeah, it is question 57. So 57,
Yeah.
57 and 58 are similar questions. You answer them the same way. So,
Okay.
all right, if you want, I can go over the 57.
Yes, please.
Okay, how many different 8-bit strings can be formed with 0 and 1? 2 to the power 8. It's just the way we did this one.
So we would do 8 boxes and then do 2 in all.
Yes.
8, right?
Right. There'll be 8 boxes, 2 ways to do each one.
Then for part B, would we write 8, 3, combination,
8,
comma 3?
yes, combination 8, 3. Exactly.
Okay, thank you.
You're welcome. Okay, anything else from the page 4 here? All right, moving on to next page. Okay. I'm at the last problem now. Feel free to ask your question from anywhere now.
I was gonna ask if you could help out with 65.
Okay.
Because I have an issue with trying to basically put the numbers in the correct spots.
Okay, but you had to remember the rule. You should always put the number in the section only for the section. If you know the section only, don't put the number, any other number in a section. That will confuse you. That'll end up getting everything messed up. So only for each section, you can put the number down. If you have already that number available. I'm going to try to copy this again. Okay. Okay, so we need to put the numbers in the right sections. First of all, it says 44 residents. So 44 is the universal set count, 44. And 25 read New York Times. So I'll use T for times, T for this at New York Times. And number is 25, 25 here. And then 20 read Wall Street Journal. I'll call J to mean journal, 20 is the number. Then it says 10 residents, no, 15 read US News. I'll use N to mean news and 15, okay, put that number outside there. It was also found that 10 residents read both New York Times and US News. I cannot put that number down because it's not one of the sections. It's equal to these two sections together. That's what that number is. So I'll move on, I'll read on and see. 7 will read New York Times only, and 2 will read US News only. 4 will read all three. That's the number I need. 4 read all three newspapers. So that number 4 goes here, all three newspapers. So
wouldn't the 10 go in between Times and the news?
10 residents read both New York Times and US News. The 10 will be, okay, so this is Times, New York Times. This is Journal. The 10 is going to be all of this, right? Understand?
Why, if it says New York Times and US News?
Oh, I'm sorry, is that what it says? Sorry, I'm reading it wrong. 10 read New York Times and US News. Sorry, yeah, that's not correct. That would be, this is New York Times, US News is down here. So all of this will be the 10.
Okay.
Okay, so the 10 includes the 4 here. So I have to subtract the 4 from the 10 to get this number here, 6. Okay, you follow me?
Yes.
All right. So that gives me 4, 6 here. And then there was another number we skipped. 10 read New York Times and US News. Okay, yeah, so all right, we got that. Now the 7 read New York Times only. So where do I put the 7?
In New York Times circle?
In New York Times, just this.
All the intersections?
Yeah, not the intersection, the part that is not intersecting any of them.
Yeah, I said without the intersection.
Right, outside the intersection. So this is the 7, New York Times only. So the people in this section are reading New York Times only, so that's 7. And 2 read US News only. So 2 will go in here, US News only. So that's all the numbers given to us. So let's calculate the other ones. Now in the circle for N, US News, I have the total count 15 available. So I can add 6 plus 4, 10 plus 2, 12, take away from 15 to find this section. And so that's 3 here. Let me use a different color to write the calculated numbers. 3 goes here. And then going to Times, New York Times, 3 sections are available. The total count is 25, so add them up. 6 plus 4, 10 plus 7. 6 plus 4, 10 plus 7, 17. Take away from 25, 8 goes here. And now go to the journal. You have 3 sections available. 8 plus 4 plus 3. That's 15. Take away from 20, you get 5. Finally, to calculate the outside, I'm going to have to add up all the sections. So all the sections in T add up to 25. We already know that. So therefore, 25 plus 5, this 5, plus 3, plus 2. That'll be 30, 35. So all the sections in the 3 circles add up to 35. So take away 35 from 44, that's 9. So 9 elements outside. Okay, so we have all the numbers now. So we are ready to calculate the answers. Let me clear, oops, let me clear these here. Okay, now the first question says, how many residents do not read any newspaper? Which number is that?
9.
9. Part B says, how many read both New York Times and Wall Street Journal? Anybody?
12.
12, the 8 and the 4. New York Times and Journal, so that's this region right here. This entire region is the common region for Times and Journal. So that'll be 8 plus 4, 12. Part C is how many read Wall Street Journal and US News, but not New York Times. So Wall Street Journal and US News, that'll be 4 and 3, but it says Wall Street Journal and US News, but not New York Times. That'll be what? Which one?
It's just 3.
2?
No, 3.
3,
I'm
right.
saying 3.
3 is right. This 3 right here. That's our answer. So 3. Part D is how many read Wall Street Journal only? Anybody? Journal only?
5.
5 is right. Part E is how many read New York Times or US News, but not Wall Street Journal. Now remember, or means you had to, that's union right there. New York Times and US News need to be combined, and you had to be outside journal. So what numbers will be combination of Times and News, but
7, 6, and 2.
7, 6, and 2. The 7 here, 6 here, and 2. These are the ones that are in the union of Times and News, and they are outside journal. So 13 plus 2, 15. 15 is the answer. The last question is, how many read neither New York Times nor US News? So New York Times and US News, you have to be outside of Times and News. That'll be what numbers?
5 plus 9.
Right, 5. The 5 here and the 9 here. These are the ones outside Times and News. So that's 14. That finishes that. Now, any question from anywhere, or even the WebAssign. But on WebAssign question, I can only explain to you without actually doing the problem because it's for credit. So I cannot work it out for you. I have the so if there is any problem you tried and you couldn't figure out, I can help you figure out, but I will not be able to do it all the way. But remember, your test is going to be on web design and it will look like this. You know, there'll be, the questions will look like this.
I have a question. Would you possibly be able to show us how to use the graphing tool on WebSun? Because I keep having an issue trying to graph my solutions.
Okay. Yeah, I can. You know, right now this is, oops, should, let me go to student view. Okay. All right. Now I should be able to show you how to work with that. Question 1 says 8x minus 3y equal to 24. So now each one of you get different version of the question. Same thing in the test also. Each one of you will get different version. So the numbers will be changed and, you know, pretty much the answers will be completely different for all of you. So I'm going to work with the numbers I have, but the numbers you had were different. So 8x minus 3y equal to 24. So let me write that here. 8x minus 3y equal to 24. So I'm going to find 2 points. To find 2 points, you can use any values for x and y, but I'm going to use zeros. If I use x equal to 0, I'm getting minus 8 for y. If I choose y equal to 0, I'm going to get 3 for the x. So 0 minus 8 and 3, 0. 0 minus 8 is on the y-axis. So you choose just to highlight the point. You don't really have to highlight the point, but to for you to be able to see where your point is, you need to pick up this point tool and put it there. That's 1 point. The other one is 3, 0. So 3 is in the middle right here. 3, 0 is right there. So now you need to join them by a line. So select the line tool. There are several line tools. If you click at that, you get this. That's just an array. This is just a line segment. None of those will be graph, the full line. So you have to pick up this full line and then click at 1 point and then click at the other point. It'll show you the line. Okay.
Okay, thank you. Because what I was doing was just selecting the points rather than selecting the correct line.
Okay, you need to mark the points and then choose the line, and then
as well.
After you choose the line, you have to go back and click at those 2 points again.
Okay.
All right. Okay. I showed this on the first day of classes for everybody, how to work with the graphing tool. So if anyone wasn't there on the first day, then you have no idea. That's probably what happened.
Professor, I have a question.
Yeah.
Do we have more than one try on the exam, or is it going to be just one?
Oh, only one. Yeah, okay. In the homework, you have 3 chances, right?
That's right.
At the test, you have only 1 chance. So you have to, and it won't tell you whether it's right or not. Okay, you just have to.
Okay, so once I submit it, I can change it.
Once you submit it, you cannot change it, yes, because you have only 1 chance.
All right.
How many questions are on the exam?
30.
Okay.
30
And we can't use our phone as a calculator, right?
No, you cannot. You have to have a separate calculator. And the calculator, you need a scientific calculator because you need exponents in some questions, right? Like you just saw the question, 8 to the power 7, right? So things like that. So you need exponent. Other than that, you don't need the scientific features. But, you know, scientific calculator is generally needed. If you have a graphing calculator, that will be fine. You can use graphing calculator. Yeah, there are a few comments I need to make. When the test will be available only at the time you can start, which is 12:15. You join the test by the Zoom meeting. You can only take the test after you join the Zoom meeting. And your video must be on, audio should be off actually, so that we don't have to hear your noises. The video must be on for all of you. If you have some problem with the video camera on your computer, then you can put the phone, you can join the meeting on the phone as well as on the computer. You can join both ways. And then put the phone on the side so that I can see what you're doing. I have to be able to see what you're doing. So if the camera has a problem in your computer, you can have the phone as a camera. But that's all you can use the phone for. You cannot use the phone for anything else. And remember, the rules are, I mentioned before, but the main rule is no communication device of any kind can be used during the test. No communication media, no social media, none of that can be used. You should be only working on the test. And if you get distracted with other things, you won't be able to finish the test anyway. So, you know, you have limited time to finish the test. So you should be fully focused on the test. Okay, so it'll look like this, but there'll be show my work area. And if you open that work area, you'll be able to type your work here. And so you cannot really show your work for this kind of problem, solving a system of 2 equations. That's too much typing. I wouldn't want you to do that. So you only enter the answers for these. So the problems for which I expect you to enter the work, which is not really work, but partial answer, will be like this. Problem number 8. Cindy has 32 coins and dimes and quarters amounting 515. So there are going to be 2 equations, and you enter those 2 equations here. You're going to enter the answers here. If the answers are correct, then I wouldn't even look at your work. Only if the answers are wrong, I'll be reading your equations here to give you partial credit. So just type the equation like this: x plus y equal to 32. Now you don't even have to tell me what x and y are. Just type the equation like that and enter the second equation there. And that's all the work I need. These 2 equations will give you half credit or sometimes more than half credit. So by showing that, you are allowing me to give you partial credit. So that's one place where you need all these application problems of the word problems, application word problems for system of equations. For the other ones, you just enter the answers. And the only other place where I would need your work is going to this question: how many 4-letter passwords can be formed using these letters? So that will be passwords means you had to choose 4 letters from this, and rearrangements will be different passwords. So therefore, order matters, and therefore it's permutation. So you enter here P permutation of, there are how many letters? 6 letters there, and we are making 4-letter password, so 6, 4. And that's the answer for part A. So you need to say A is this, and then B is whatever it is. Type that. That's all. That's all the work.
So you would just want us to include the permutations to show our work?
Yes, just that description. It's P64. That's all I need. I don't need to see how you simplify that. I don't need to see that. Then you simplify and enter your final answers in the boxes. Okay.
Okay.
So only if the answers are wrong for partial credit, I'll be manually grading your work. So if your answer is correct, then you'll get the full credit and I don't need to look at the work. So the work is for partial credit. And if you don't want to bother with that, I would recommend doing the entire test first. And then if you have the time, go back and enter these work, because it's more important that you finish the test. So that'll be my recommendation. So if there is enough time to go back and put the work in, you do that. But I will be giving half an hour extra time. So instead of finishing the test at 1:30, you will have time until 2 o'clock. Okay, so you have to finish it within that time. Any other question about the test? All right, so that means we're all set. Remember to bring your calculator and make sure there is some way I can see you working with the test. If it is not the camera on the monitor, then it has to be some other camera from a laptop or phone. Something has to show me that you are the one sitting there and doing the test. All right, so if there's no other question, we're all done. And good luck in the test. And I will see you Wednesday at 12:15 in the exam.
Thank you so much, Professor.
You're welcome. Have a
Thank
nice
you.
day, everybody. If you
Thank
have
you.
questions, stick around. Otherwise, you can leave. Have a nice day.
Thank you. Have a nice day.
Thank you. Bye.
Thank you. Bye-bye.